Okay guys, continuing on with number 63, what is the area bound between this curve and the x-axis? Basically, the picture that you should have in your head is that this graph here of this quadratic and the x-axis probably enclose or surround some region, and they're asking you to find the area of that region. Of course, this is a quadratic, it's a parabola, it's pretty easy to know what the graph is. I would start by finding the x-intercepts. You're going to need those. Set this thing equal to 0. You get x times 3x minus 6 equals 0. So that's going to give you the solutions x equals 0 and x equals 2. Sorry, x equals 2. So what that's telling me is the graph looks something like this. We've got the x-axis here, and then maybe 2 is this value right here, and let's say 6 is this value right here. This is a quadratic that opens up, so I think the graph is going to look something like this. And the area bound by the curve in the x-axis is this region right here, okay? So what is that area? Well, what we're going to do is we're going to integrate between these two values. So those are the x-intercepts. We're going to integrate from 2 to 6, sorry, from 0 to 2, right? We're going to integrate from 0 to 2, and that's going to give us the area. Actually, I think it's going to give us a negative number because this region's below the x-axis. But since the question is just asking for the area, we should take that number and make it positive. So I'm going to do the integral from 0 to 2 of this function here, 3x squared minus 6x dx. So I'm going to find an antiderivative. I think that would be x cubed minus 3x squared. And now I need to evaluate this guy from 0 to 2. So what would that give me? I'm going to plug in 2, I'm going to plug in 0 and subtract. Plugging in 2 would give me 2 cubed minus 3 times 2 squared minus the expression evaluated at 0, which would be 0 cubed minus 3 times 0 squared. And that's going to give me 8 minus 12, which is negative 4. As I predicted, the number's negative because this region's below the x-axis. We just want the regular area, though, so the answer is just positive 4. Number 64, what is the derivative of this function? Straightforward, it's a chain rule question. I would start by rewriting this as quantity sine 2x all squared. So it's actually going to be like a double chain rule because it's a function inside a function inside a function. So the outside function is blank squared. So the derivative of that is 2 blank to the 1. And the original inside function goes inside there times the derivative of the inside function. But of course, the inside function itself is pretty complicated, so maybe I'll just write the inside function and put a prime and compute the derivative in the next line. So I'm just going to copy all of this. I don't need that exponent of 1. Okay, and now I need to multiply by the derivative of this guy, but you know, that's a composition, right? 2x is a function. So chain rule says it's 2 cosine 2x times 2. So I actually get another factor of 2. So f prime of x is going to be 4 sine 2x cosine 2x. That should be one of the answers. Number 65, looks like they want you to find the equation of the tangent line to this graph at x equals 0. Whenever you want to find the equation of the tangent line, you should write down point slope form. Y minus y1 equals m times x minus x1. You need to then find the x1 and the y1 and the slope. The x1, y1, like that's the point on your curve. x1 is definitely 0. To find the y coordinate of the point, you plug 0 into the original function. Of course, if you plug 0 into this original function, you're just going to get 0. So the point that we're looking at here is 0, 0. That's your x1, y1. We also need to figure out the slope of the tangent line, your m, but that's just the derivative of this function at x equals 0. So I need to find the derivative and plug in 0. The derivative would be 2x minus 4. If you plug 0 into that, you get, so y prime of 0 would be negative 4. So that's your slope, m. So you're going to get y minus y1, which is 0, equals m, which is negative 4, times x minus x1, which is 0. If you simplify all of that, you're just going to get y is equal to negative 4x. That should be one of the answers. Number 66, use linear approximation to approximate root 15. I think that what you should do is write down the equation of the tangent line. There we go, tangent line of y equals square root of x. And you should write down the equation of the tangent line at a perfect square, at a nearby perfect square, so I would say it's 16. So I'm just going to write the equation of the tangent line to this function at 16, and I'll use that to approximate root 15. So once again, just like the last problem, I need to write down point-slope form. Every time you write down the equation of a tangent line, you use point-slope form. I need two things. I need a point on the line, and I need the slope of the line. So the point on the line, of course, the x-coordinate of the point is 16. To get the y-coordinate, I plug 16 into my function, right? If I plug 16 into that function, I get 4. So 16, 4 is the point on my line. That's the x1, y1. The slope, of course, your m, that's going to be the derivative of this function evaluated at 16. So I need to take the derivative. Y prime is equal to, it's going to be 1 over 2 root x, right? Like 1/2 x to the negative 1/2. And if you evaluate that at 16, you get 1 over 2 root 16. So that's 1 over 2 times 4, so 1 over 8. So that's your m, that's your slope. So the equation of the tangent line is therefore y minus 4 equals 1/8 times x minus 16. And now to approximate root 15, I just plug 15 in for this x right here. So that's going to be y minus 4 equals 1/8 times 15 minus 16. And now I just need to solve for y and simplify. So this is y minus 4 equals, well, 15 minus 16 is negative 1 times 1/8 is just negative 1/8. So I'll find that y is equal to 4 minus 1/8, which is 32 over 8 minus 1 over 8. So I think it's 31 over 8. That should be one of the options. Oh, they're giving mixed numbers. So stupid. Yeah, I guess that would be 3 7/8 or something. Okay, number 67, let f be the function given by this guy. On which of the following intervals is f increasing? Function is increasing when its derivative is positive, so you need to do a sign analysis for the derivative. The derivative is 300 minus x squared. We need to ask, when is this function 0 or undefined? It's never undefined, so we'll just set it equal to 0 and solve. You'll get 300 equals x squared. You'll get, oh, I screwed this up. The derivative is 300 minus 3x squared, isn't it? Forgot about the 3 there. So I get 300 equals 3x squared. So 100 is equal to x squared, so therefore you get plus or minus 10 is equal to x. So on our number line for the sign analysis of the derivative, you've got negative 10 and positive 10. And so we have those three regions to consider. If you plug in a large, like, positive number, pretty sure that that region's gonna be negative. If I plug in a number from here, a good one would be like 0, that's positive. And if I plug in a large negative number, then I think you're going to get a negative number here. So this is your sign analysis. So when is the function increasing? Well, when its derivative is positive. So that would be between negative and positive 10. Okay, number 68. Let f be the function given by, well, actually they're giving you the second derivative here, not f. What are the x-coordinates of the points of inflection of the graph of f? Well, that's going to be a place where, I mean, remember, inflection points are a place where concavity changes. Concavity can be understood at the level of the original function, which means the graph is happy or sad, at the level of f prime, which means f prime increasing, decreasing, or f double prime, and that's where f double prime changes sign between positive and negative. So basically you need a sign analysis of f double prime. Of course, this is a formula for f double prime. So, so you would set this function equal to 0 to get the numbers on your number line. If you set this thing equal to 0, you'll get three values, 0, 3, and 6. So, like 0 and 3 and 6 right here. And now the question is, does the second derivative actually change sign at these points? You can figure that out very quickly if you know your multiplicity stuff. Like 0 comes from the x squared, which has an even exponent. That's even multiplicity, so the sign will not change at 0, which means that 0 is not an inflection point. But 3 and 6 have odd multiplicity. They have multiplicity 1, so the sign will change at those two values. So the concavity is actually changing at those two values, so 3 and 6, but not 0. Number 69, we have f of x is increasing. Wait, what are we given here? This is the graph of the derivative. Okay, fine. Where is the original function f decreasing? Well, the original function f, again, this is not a graph of f. You're not asking where this function is decreasing. You're asking where the original function is decreasing. The original function decreasing occurs when its derivative is negative. And here's a graph of the derivative. So we're asking when is this graph negative? And that would be right here between 0 and 3. All right, so that's number 69. Number 70, when is f concave down? Well, again, they're not asking when this graph is concave down. They're asking about the original graph. F being concave down, what does that mean at the level of f prime? It means f prime decreasing. So we're asking when is this graph decreasing, and that would be from here to here, from 5 to 8, but also from like negative infinity to 1. That's where that graph is decreasing. Number 71, when is f prime concave down? Okay, now they're talking about this graph, right? Unlike the previous problems. Now they're talking about the graph that's actually shown. When is this graph concave down? Well, that's just when the graph looks like a sad face. So that would be like along here from 3 to, I don't know, maybe, I guess this point is what they're trying to indicate here, that the concavity changes here. From 3 to 7, it looks like it's concave down, and I think that's it. I think that's the only place that it's sad. Number 72, where does the original function f have a relative minimum? Well, if you want to know about relative minimums and maximums of a function, what you need is a sign analysis of the derivative. I have a graph of the derivative right here, though, so it's very easy for me to figure out where f prime is positive and negative, right? So, like, this is f prime, right? And you can see that f prime is 0 here, and f prime is 0 here, and f prime is 0 here. And from the graph, it's clear that f prime is positive on this region, and then it's negative here, and then it's positive here, and it's still positive here. So I have a sign analysis of f prime, which should allow me to find any minimums or maximums of the original function. So the original function, since f prime is positive here, the original function's increasing, then decreasing, then it's increasing, and then it's still increasing. So what are they asking for? A relative minimum? Yeah, the relative minimum happens right here. I kind of misaligned my lines there. But yep, that's happening right here, which is at 3. That would be the relative minimum. And then, this is a maximum, and this is like a plateau or something. So number 73, when does f prime have a relative minimum? That's easy because they give you a graph of f prime. So where does this graph have a relative minimum? Right here at 1, the end. 74, find the average value of x squared over that interval. Yep, that's just a formula. It's 1 over 6 minus 3 times the integral from 3 to 6 of x squared dx. You're not supposed to use your calculator on this stuff, so you're going to have to compute that integral manually. So 1 over 6 minus 3 is just 1/3. And then we need an antiderivative to evaluate this integral. An antiderivative of x squared would be 1/3 x to the third. And we're supposed to evaluate this guy at 3 to 6 and subtract. So that's going to be, well, the two 1/3s, you can put those together to give you 1/9. So it's 1/9 times 6 to the third minus 1/9 of 3 to the third. 6 to the third is a rather large number to be computing, like, without a calculator. I'm a little surprised to see it in this problem. There are some shenanigans that you could sort of pull if you really wanted to, because, like, there's some common factors here, but the exponent makes it weird. So maybe you should just do 6 cubed manually. I mean, 6 squared is 36, so what's 36 times 6? Well, 30 times 6 is 180, and then 6 times 6 is 36, so it's 180 plus 36, so I think that's 216? I think that's 216? Let me just double check. 6 cubed? Yeah, 216. Yeah, so that would be 1/9 of 216 minus 1/9 of 3 cubed is 27. Yeah, this problem's kind of annoying arithmetically. And so I would view this way, probably, is what I would do. Like, factor out the 1/9. And then, what is that? I don't know. 216 minus 27. Is that 189? Is that right? Yeah, that's right, 189. And then, what is that? I don't know, use long division. I'm tired of this problem. Sorry. Okay, number 75. Okay, so 3 over 4 plus x squared prime is equal to blah, blah, blah. We're just taking the derivative. Don't use the quotient rule. You really don't need to. It's a lot easier to just rewrite the function as 3 quantity 4 plus x squared to the -1. You could use the quotient rule, but I don't know. If the numerator is constant, like, if either the top or the bottom are constant, you shouldn't be using the quotient rule. It's kind of overkill. It's more efficient to just rewrite it. So this is a composition, though, so you're going to get -3 times 4 plus x squared to the -2 times the derivative of the inside, which is 2x. And then, so I think simplifying, that's going to be the 4 plus x squared, quantity squared goes in the bottom, the -3 times 2x gives you -6x. Is that one of the answers? Yep, looks like it is. Cool. Number 76. Suppose the area of a circular what? A circular region, presumably, is increasing at a rate of 96 pi square centimeters per second. What is the area of, when the area of the region is 64 pi squared centimeters, or pi, yeah, how fast is the radius of the region increasing? This is a related rates problem. Okay, they're talking about area of a circle, they're talking about radius of a circle. You need to write down an equation which relates those two things. I think that's obviously a equals pi r squared, just the area formula. And then you're going to take the derivative of both sides, remembering that everything is a function of time. So you get like a prime equals 2 pi r prime, right? Because r is a function of time. We're taking the derivative with respect to time. And now we plug in what we know. Well, we want to know how fast is the radius increasing. That means we want r prime. In order to use this equation, we need to know everything else in this equation. And we know a prime. We know a prime is 96 pi, but we don't know r. However, we can find r because we're told that at this moment the area is 64 pi. So I can plug that into the original area formula to get this, and then find r. So you can divide both sides by pi. You get 64 is equal to r squared. So r is going to be 8. It's obviously positive 8 because it's talking about the radius of a circle, so it's positive. So going back to this guy, that's going to give me we know that a prime is 64 pi, so that equals 2 pi times r, which we said is 8 r prime. And then, let's see, this is like 16 pi over here, so divide both sides by that. I think you get 4 is equal to r prime. 77, y is equal to sine 2x, then dy is, oh, yeah, this is, I forgot that this problem is on here. You can ignore this one. You know, what's up with the dy? Like, yeah, I would just forget about this problem. Okay, just don't even worry about it. 78, they want you to find the antiderivative of this. This is just like the one that was on the unit test we just took, and guys, you did not do well. So you should, like, take a hard look at this problem. I saw a lot of people on the unit test trying to, like, rewrite this denominator as like having a negative exponent and then multiplying the numerator. I can tell you that I think every single person that tried to do that got it wrong. I think every single person that tried to do it. You should split the fraction, okay? Which, boy, I've told you that before, but, you know, whatever. So if you split the fraction, you get this, and then plus 2x over 2x dx, right? And then you can reduce each of these guys. This first term here just simplifies to 4x squared, and then plus 1, I do believe. Okay, now we can take the antiderivative. So that is going to be 4/3 x cubed plus x plus c, I do believe. Yep, looks like that's one of the answers. Cool. Number 79, find the x-coordinates of all points of inflection of the graph of blah. Well, you know, I would say you should do a sign analysis of f double prime. So y prime is 20x cubed minus 5x to the fourth. So y double prime would be 60x squared minus 20x to the third. Set this guy equal to 0. If I pull out common factors, I get 20x squared quantity 3 minus x, I think. Let me just double check that. Yeah. And yeah. Okay, so I have I'm going to have two solutions to that. One of them, of course, is 0, and the other one is 3. You know, if you plug in a test point like 1, for example, if you plug in 1, it's going to be negative here, I do believe. No, it's positive there. It's positive there. It's going to change sign at 3 because the multiplicity is odd. It's not going to change sign at 0 because the multiplicity is even, so it's still going to be positive at that location. So this is the sign analysis. You can see that the second derivative changes sign at 3 and 3 only, so 3 is the only inflection point. Number 80, the graph of f prime is shown to the right. If f of 6 is equal to 4, then find f of 9. This is like stuff that we just did on the unit test. This is like, you know, you have an earlier value and you want to find a later value and you have information about f prime. you want the integral as net change formula, which says f of b equals f of a plus the integral from a to b of f prime of x dx. Some of you screwed this up by like switching these around. Like the order matters. Like b goes here, a goes here, a goes here, b goes here. Like you have to put them in the right places. So yeah, so in this problem, I would say that b, the later value, is 9. So you'd say f of 9 is equal to f of 6 plus the integral from 6 to 9 f prime of x dx. And then, of course, you can say, well, f of 6 is equal to 4. So it's 4 plus, and then what is this? Well, it's the signed area under this graph right here, because this is a graph of f prime. So what is the area between 6 and 9? Well, 1/2 base times height for the triangle. 3 by 2 is 6. I think this area must be 3. Of course, it's negative 3, right, because it's below the x-axis. So that'd be a negative 3. So that's going to be 1. So I think the answer is 1. Number 81. If f of 12 is equal to 30, then find f of 0. Yeah, this is kind of the same thing. I'd say you can write later value, like f of 12, equals earlier value plus the integral from 0 to 12 f prime of x dx. F of 12 is 30. That's going to be equal to f of 0, which we want to know. Plus, and then this guy is just the signed area under the curve. So what is that area? Well, let me see. So what is this region here? 1/2 the base. So the base is 9, and the height is 2. So 1/2 9 times 2, that's 9. So the area of this guy is 9. Of course, it's negative 9, right, because it's below the x-axis. And then up to 12, you're just looking at this portion here. That guy there is 1/2 3 times 2, so that's just 3. So the total value of this integral would be negative 9 plus 3, that's negative 6. So you find that 36 is equal to f of 0. Cool. 82. One is f decreasing. Well, f is decreasing when its derivative is negative. You've got a graph of the derivative right here, and that function is negative from 0 to 9. So from 0 to 9. That's number 82. Number 83. A 13-foot ladder leans against a building. Blah 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 blah. Yeah, it's a related rates problem. I would give some names to these things. Maybe call this x. Maybe call this y. What do we know? We know that x squared plus y squared is equal to 13 squared by the Pythagorean theorem. We're also told that the base is slipping away at 3 feet per second. That means x prime is equal to 13, positive 13, because x is increasing. And it also, and it wants to know at what rate is the top of the ladder dropping. So in other words, we want to know y prime. At what rate is the top of the ladder dropping? When the base is 5 feet to the left of the building, that means that x is equal to 5. So I'm going to take the derivative of this equation here, plug in the known information, blah, blah, blah. That's 2x, x prime, plus 2y, y prime. Remember, x and y are functions of time here. The variable is time in a related rates problem. Equals 0. Right, like it's not like y is a function of x. It's not. X and y are both functions of t, time. Yeah, so plug in what you know here. You get 2 times x, which is 5, times x prime, which is 13, plus 2 times y, which I don't think we know what y is, but you can find it by going back to this original equation here. X is 5, so you got 5 squared plus y squared equals 13 squared. So what is y squared? I want to say it's 12? Is that right? Again, kind of not a great question for a non-calculator, but 13 squared minus 5 squared is 144. Yeah, that'll give you y equals 12. So 2 times 12 times y prime, which is your unknown, equals 0. Solve that equation for y prime and you're done. 84, yeah. Okay, so 84, f of x has the property that limit as x approaches c, f of x equals f of c, which of the following statements must be true? This is an old one. This is actually the formal definition of continuity. That is the definition of what it means for a function to be continuous at the point c. We usually don't think of it that way. We have like a graphical interpretation of it. But if you go way back to like Unit 1 and look at the definition of continuity, that is what it means. This equation right here means that the function is continuous at c. So it's definitely, 1 is definitely true. 2 is definitely not necessarily true. Like, a function can be continuous without being differentiable, so 2 is not necessarily true. Number three is true, because in order for this original equation to be true, everything in it needs to be defined. In particular, this two-sided limit needs to be defined, and that means that the left and right-hand limits must be equal. So 3 is also true, so it's 1 and 3. Number 85. If f is differentiable at c, which of the following statements must be true? This guy has to be true because that means the function is continuous. As I said in the previous problem, that is the definition of being continuous at c. That's the old definition of continuity. So, and you might remember that in order to be differentiable, the function needs to be continuous. So, since it's differentiable, it's definitely continuous, which means that this equation must be true. So 1 is true. What about 2? That's definitely true as well, because this is a formula. I mean, that's the definition of the derivative of the function at c. That's the definition of the derivative. And so if the function is differentiable at c, being differentiable at c just means the derivative is defined. The derivative exists. So this limit has to exist because that is the derivative. So that's definitely true. And then this guy here, limit as x approaches c from the right, f prime, yeah, this also has to be true because actually, I'm not 100% sure on this one. Oh, yeah, no, because this is saying that the slope as you approach the point from the right is equal to the slope of the function as you approach from the left. And those two things should be the same, because if they're not, that would imply you've got some kind of corner, right? Like the slopes aren't matching at c, but we're told that the function is differentiable there. So I think that 3 has to be true as well, although like I'm slightly nervous about that one. Number 86, at which values of x does y equal blah 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 have a critical point that is not a relative minimum? Okay, so we're looking for critical points that aren't relative minimums. Alright, so I guess I should find the critical points and do a sign analysis of f prime. Y prime is equal to 15x to the 4th minus 15x squared. Alright, yep. So critical points, places where this thing is 0 or undefined. It's not undefined anywhere, so I set it equal to 0. There's a common factor of 15x squared, x squared minus 1. Is that right? I think so. Yep. Equals 0. Set each factor equal to 0. You're going to get 3 solutions. You're going to get x equals 0, and x is equal to plus or minus 1. So there's 3 values. We've got -1, we've got 0, we've got +1, and what is the sign analysis? Maybe it would be helpful to show how I get the plus or minus. You can factor this. This is a difference of 2 squares. That's, x plus 1 times x minus 1. Okay. Anyway, okay, a test point. Let me see. Like this region right here, let me pick a test point from here, like 1,000,000. Plug in 1,000,000, and you're going to get a positive number. Okay, so like the function's positive here. The multiplicity of +1 is 1, so the function will change sign there. However, the multiplicity of 0 is 2, since it comes from here, so the function will not change sign there, so it's still going to be negative. The -1 comes from here, the multiplicity is odd, so that's going to be positive. And so that's my sign analysis, and we want to know at which points does it not have a relative minimum. That's kind of a weirdly negative way of phrasing it. The original function is increasing and then decreasing, still decreasing, and then increasing. So I'd say you've got a local minimum at 1, and that's it. I think -1 and 0 are both not relative minimums.